All right, Math 5130, Statistics for Healthcare Professionals. We began hypothesis testing, and the first example of a hypothesis test that I want to share with you, I want to teach you, or maybe it's a review, is for a population mean. So, example I kind of want to run through is, let's say someone has made a claim that the mean hospital stay for the delivery of a baby in this particular area using the birth data stat crunch is $20,000. So for a test of hypothesis and statistics from 30,000 feet, we essentially are kind of addressing three components. Number one, we're going to formally state what we're going to test, and we're going to state the level of significance that we're going to test at. Next thing we'll do is we'll compare our sample data to the claim. If it's really close, then there's no reason to really suspect the validity of the claim. If it's a long way away, then maybe we suspect that the claim is not true. And again, there's a very rigid procedure for that I will teach you. And then we ultimately make a conclusion and state our results. So hypothesis versus hypothesis test. In general, I think hypothesis is a kind of an educated statement. In this case, for statistics, it's an educated statement about a claim or a statement about a value in a population. Hypothesis test is just a formal procedure for testing the claim. First thing we're going to do is we're always going to state our null and alternative hypotheses. The null hypothesis is a statement that a particular value of a population parameter is equal to some value. So someone has made a statement that they feel, they believe that the mean hospital stay is equal to $20,000 in this particular region. The alternative hypothesis kind of drives the test from our perspective. If we want to test that claim, for some reason we don't believe it's 20,000, or maybe we're just in an argumentative mood and we want to test it, then we must think that the statement is untrue. The alternative hypothesis represents what we want to test. Now, there's three different forms, and only one of them can be used. If you look down at the bottom, and I've highlighted the first one, H sub A is the alternative hypothesis notation. The mu is not equal to 20 is something we call a two-tailed test. We may want to test that the mean is equal to 20,000 because we think it's less than 20,000. In that case, we would use the second. Or maybe we think it's higher than 20,000, we would use the third. The second and the third test are called one-tailed test or directional test. The not equal to is called a two-tailed test. From my perspective, I would never, ever, ever use a directional test other than textbook examples. Now, my stat lab, you're going to have some problems where they ask you to run a directional test. That's fine. I think in terms of learning the process, I think that's just fine. But in terms of actual application of a t-test, a hypothesis test for a mean, I would always test not equal to. And I'll explain to you later why I prefer this approach. The next thing that we do is we select the significance level. There are only five that I've ever seen, or I'm sorry, only three I've ever seen, 0.05, 0.01, or 0.10. 0.05 is by far the most common, and it's the only significance level that we will use in this class other than my stat lab. And my stat lab may have you, again, in the spirit of learning, it may have you use 0.10, 0.25, or 0.001. So in terms of learning the process, it's okay to vary alpha and compare p-values and things. But for any write-up, any discussion forum post, we will always use 0.05. And we'll always use 95% as our confidence level. The next thing we do is we calculate the test statistic and the p-value. We will use technology to do this. The test statistic is just a metric for comparing our sample data to the assumption that's given in the null hypothesis. So it kind of compares our sample data to the assumption that the null hypothesis is true. The p-value is the probability of getting our test statistic that is at least as extreme as the one that we calculated from our sample data, again assuming that the null hypothesis is true. Now, for this to really make a lot of sense, you've got to dive into sampling distributions and normal distributions, and I really don't think, let's just say that we have bigger fish to fry than going down a bunch of rabbit holes, getting into the weeds about what a p-value really is. At this stage of the game, what I want you to know is we compare our p-value to our alpha value, and we make certain decisions based in the context of our research statement. So step 4, we compare the p-value to our alpha. So if our p-value is less than or equal to alpha, we reject H sub O. So we have statistical significance, or our test is statistically significant. If our p-value is greater than alpha, then we fail to reject the null, and we have a test that is not statistically significant. You never, ever, ever, and this is where I can find out who's watching my videos and who isn't watching my videos. In research, you never report the result of a t-test as reject or fail to reject. It's either statistically significant or not statistically significant. The final thing that we do is we calculate, and this is a really, really important slide right here. So let's pump the brakes a little bit and talk this through. Confidence intervals are really important to report, because even if we test alternative hypothesis not equal to, the confidence interval tells us whether mu is higher or lower than the hypothesized value. The hypothesized value here is $20,000. Now let's examine that first confidence interval. And again, it's a hypothetical one. We'll calculate the real confidence interval in the next video. But the hypothetical confidence interval from 15,000 to 18,000, notice that the entire interval is below 20,000. In this case, we would have statistical significance, and we would conclude that the mean hospital stay for all stays in this region is actually lower than the hypothesized value of 20, or the claim of $20,000. On the other hand, for the second bullet, if both of our endpoints of the confidence interval are higher than 20,000, so 23,000 to 26,000, that entire interval is higher than 20,000. So again, we would have statistical significance, and we would conclude that the mean is higher than $20,000. Now, if our confidence interval contains the hypothesized value, and in this case, again, it's $20,000, so the hypothetical confidence interval from 18,000 to 21,000, notice that 20,000 is contained in that confidence interval, so therefore we cannot reject that the mean hospital stay in this region for the birth of a baby, a delivery of a baby, is $20,000. Then in that case, we would our test would not be statistically significant. So the first two hypothetical confidence intervals, we have statistical significance. The bottom, we have not statistical significance. So for the top two intervals, my p-value would definitely be less than my alpha. For the bottom one, my p-value would not be, well, my p-value would be greater than alpha. Okay, that's all I got. I think this stuff will start to come together when we dive into a data set. Take a look at that. All right, take